settlement success with Diploria labyrinthiformis under different conditions. Go ahead.
Thank you. Whew. Okay. Good morning, everyone. Most of the people in the room are probably very familiar with the process of assisting the sexual reproduction of corals. We basically do the math with the full moon, then we monitor the adult colonies, we check them for spawning, and then once they spawn, we collect their gametes, then we assist fertilization. Then we look at the cellular divisions, wait a couple days, then they become larvae, then we finally offer them some substrates and some CCA, and we let them settle. But what happens next? So, how many of these larvae die in the process? Why do they die in this process? Can these larvae swim to further distant reefs and replenish these degraded reefs? How many of these larvae that settle actually survive, or how long do they survive for? There are a lot of questions that still remain to be answered about coral larvae and coral babies, and of course I cannot answer all of them, but I decided to start with one question. And this was, what happens when larvae get stressed in the settlement process? But more specifically, how is ocean warming affecting coral settlement? And if settlement-inducing CCA gets sick, what do larvae rely on? So my name is Nepsis Garcia. I am a graduate research assistant at NSU with Dr. Figueredo. But 2 years ago, I was a research intern at TNC research intern at Fundemar, and with this amazing team, we decided to answer this question. So what we did to answer it was, first, we chose a CCA species and a coral species. So we worked with Hydrolithon boergesenii and with Diploria labyrinthiformis. We got a bunch of D-lab larvae, and then we split them in different groups, and we gave them different substrates. And these were some diseased CCA, we gave them some healthy CCA, bare rock, and also no substrate as a control group. And we also replicated these in 3 different treatments, which were 27.5, 29, and 31 Celsius degrees. And finally, we assessed settlement and mortality every 24 hours for 6 days. And what we found was, first, that higher temperatures led to higher settlement. And this could have happened probably because the metabolic rate of the larvae got accelerated because they were under stress. And this could have made them desperate and made them settle more. We also found that larval settlement was significantly higher when CCA was present, regardless of whether it was healthy or was not healthy, which is very interesting because we know that they can actually settle in either healthy or CCA or diseased CCA. But that's not the whole story, because we also found that settlement and survival were significantly lower when the CCA was diseased. So even though they can settle in diseased CCA, this can be detrimental for the larvae. So looking at these results, we could think like, wow, it's great that even if the ocean is warming, the larvae are settling. But again, that's not the whole story, because some other studies have found that even when these higher settlements happen in heat stress, when the coral has been submitted to stress during the larval stage, post-settlement, their mortality is very high. So we do not recommend using heat stress as an inducer for higher settlement rates. This project helped us reinforce the fact that CCA is very important for settlement, but even more so that healthy CCA is very important for settlement. And this study helped me answer my first question, but there are a lot of other questions from where that came from. And I currently am working on my second question, and that is, can old coral larvae replenish degraded reefs? And if you want to know the answer to that, you can come see me at the poster session tonight, and we can talk about it. I am very passionate about coral babies and coral larvae, and as I said, there are a lot of questions that we still need to answer. I feel like they are like my children, even though I don't even know what having children is yet. But if you're as passionate and as interested as I am in this topic, I welcome you to grab me in the hallway and let's talk about it. Or you can find me in these platforms and we can work together. Thank you.
you very much.
Thank
Do
you.
we have plenty of time for questions? Yes.
How do you know? I guess I don't know what kind of lets you see except that recruits love it, but how do you know if it's healthy versus disease? Is there a visual?
Yeah, that's a great question. So there are awesome scientists that have decided to work on CCA, and there are actually some specific species that are good for certain other coral species. There's not a lot of research on CCA, but it's very interesting. There are ID guides, like this guy that I admire so much. He actually inspired me to work with this. His name is Larval Williams. He has a website, and in his website, he has like ID guides for some Caribbean CCA species, and you can identify them visually. But it is tricky to identify CCA visually. So some people would recommend that you do genetic analysis to be sure. But if you're working like in a artisanal way, you can use these guides, maybe contact some of these people to confirm the species, and then you can go from there. Yes. Yes.
When you talk about higher temperatures, how high were these stressors that you were?
Okay, very good question. Yeah, so we tested 27.5 approximately Celsius, 29 and 31, and where we had more settlement was in the 31 Celsius degrees. Yeah.
Did you monitor like the post-settlement survival of the settlers that settled on unhealthy CCA? If they stopped
No,
dying later on?
we wanted to work on that, but we did not have a great post-settlement survival, so we could not like have a good number to actually say like this happened. Yeah, but that would definitely be a great step forward into it.
How would you recognize a diseased CCA?
There are certain lesions that you can see. Let me see. I have a picture here. So this like white band
Okay, yeah.
followed by this green part. Yeah, that's one of the lesions. This is another one, and in this one you can also see like first become white and then it gets like kind of orangey. Yeah. There's a study by, oh my god, I hope I'm not butchering their last name. It's Quare and Nunn. Yeah, I don't know how to pronounce.
Yeah, so Gail Kerry and Maggie Nukes. I think there's
Yeah.
also a lot of photos.
Maggie Nunks. Okay, yeah, they have like the name of the diseases and how you can identify them and all that, and we followed their lead.
Good. Well, thank you very much.
Thank you.
Yeah. Unfortunately, our two next speakers, which we're going to cover the next half hour of talks, are not present given the hurricane. So I guess we'll be reconvening, restarting again at 12 for our last talk with Eric. It's a very important talk about financial challenges. Everybody should come back for Eric. But we have half an hour. We can just hang out here, talk, or go see other presentations in the meantime. Thanks.